Energy. On Earth, we use it every day, lighting our homes, driving our cars, for just about everything. But what about in space? In the future, NASA's astronauts will need energy resources in order to live and work on other planets. In the 1990s at the University of Arizona, K.R. Sridhar and his team were working with NASA on a technology that could use solar power to convert CO2 on Mars into oxygen for breathing and fuel. The relationship is that you're taking electricity, typically from solar panels if you're on Mars, and you electrolyze CO2, and what you get at the other end is oxygen and fuel. And the fuel in this case is carbon monoxide. Sridhar had an idea for another application of the technology for here on Earth. By reversing the original concept, the device had the potential to take oxygen and fuel and generate energy.
Literally, if you just turn the wires around like this, you can make something that behaves like a fuel cell. Now, it's not the kind of fuel cell that you could commercialize. There's a lot of changes that you need to make, but the physics works.
In 2001, K.R. and his team moved to the NASA Research Park at Ames Research Center to foster the development of their new fuel cell idea. Now known as Bloom Energy, the firm is located in Sunnyvale, California, where they are producing solid oxide fuel cells based on the original NASA work. An electrochemical device, a solid oxide fuel cell can produce electricity directly from oxidizing a fuel. Although fuel cells have been around for a long time, Bloom's product is different. Theirs are not made from precious metals or corrosive acids.
We use the phrase powder to power a lot, and the reason for that is, as you see here, just about all the elements that go into the cell itself start out as readily available powders from different places on Earth. We turn those powders into inks using, again, some chemicals and other materials, and once we've got inks, we paint the inks on these cells using a process that's a lot like what you would use to silkscreen t-shirts.
Besides its materials, Bloom's fuel cell has a couple of other advantages. They're high temperature, making them fuel flexible and very efficient.
Which means twice as much electricity for the same amount of fuel, or half as much carbon for the same amount of electricity.
The technology is also reversible.
We can combine it with renewable but intermittent technologies like solar and wind. And when the sun is out or the wind is blowing, you could take the electricity that a solar panel, let's say, would produce, run it through the system in that Mars direction, produce air, produce fuel.
Each fuel cell generates enough energy to power an average light bulb. To build large servers, Bloom stacks the cells.
This stack has about 25 cells in it, and this stack is half a kilowatt. So this would be enough to power half of an average US home, or a whole average European home, or 2 average Asian homes.
In 2008, Bloom installed its first server at Google. Since then, eBay and others now have servers helping to generate their power.
We can ultimately deploy these units in remote parts of Africa or Asia and bring power where there's no power today.
And then, who knows, maybe Mars.